Hello everyone and welcome to this week's Premiere plugin tutorial. In this one I'm going to be showing you how to set up a Premiere transition plugin. Now there's a slightly different setup required for these specific types of plugins. That is under your actual video transitions in Premiere, the ones that you can drag in between clips and transition from, in this case, image A to image B. Now, of course, transitions are going to be similar to effect plugins in that they use pixels, but today I'm going to show you kind of how to take the example that comes with the Premiere SDK, how to set it up properly, and get started creating your own transitions for Premiere. Before we get started, I do want to remind you down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly in the channel, and down in the description you can follow me on GitHub coding updates as well as Instagram of the live update. If you're not already a member of our Discord server, make sure you come and join to get help with scripting, extensions, plugins, smidge tutorial ideas, and much more. And if you'd like to help support us on YouTube, you can do so down below by becoming a member or a supporter. This comes with cool perks like badges, Discord status, access to polls and live streams, and also check out the links down below to AE Scripts, Gumroad, and Adobe Exchange to see some other cool stuff I make. Okay, so to get started, you're going to need the newest version of the Premiere Pro SDK, and inside of the Premiere SDK there are projects, GPU video filter, and a project called SDK Cross Dissolve. This is the sort of skeleton project we're always going to use for getting started on a new transition, and inside of here will be everything we need. And also what I've also done is merged this with my existing AE SDK folder, so there's going to be a few things I need to fix. So once I've opened it, I can't just build this straight out of the gate. It looks like we have some issues, namely in our param setup. We're unable to define basic UI elements. So in order to make sure I have proper reference to the files, I think I just need to add here into my additional include directories under C++ general. Because I think these particular paths may not be evaluating correctly. So let me add one to my util folder and also one to headers. Let's see if that resolves that issue. Now we have access to add our UI elements in here. Perfect. You'll also notice that with this particular project, there is both a GPU and a CPU version. This is extra helpful because not only can you learn how to make a transition for Premiere, you can also take a look at how Adobe handles GPU setups. For this tutorial, however, because I am coming out with an individual GPU tutorial which will somewhat apply to this, I'm going to just stick with the CPU portion so that you can get the basis of how to create the transition specific parts first. So in order to actually totally remove the GPU functionality, I'm going to remove the GPU file, and it says it's read only, but that's fine. We're going to remove the CL and CU files. These are CUDA and OpenCL files, which we do not need. And then we can go through and see if there's any issues that are caused by that. If you browse the actual CPU functionality here, you can see we have a render function, and there's no reference to the GPU. I believe how this works is that the setup in particular that you have for Premiere, whether you're using just the Mercury software CPU, then it will just use the CPU version. If you have GPU setup, whether it's CUDA or Metal, it will then use the GPU version. But because I don't want to have to go through all the build steps right now to get that set up, we're just going to have the CPU version. So if I actually want to test and build this, I'm going to need to close Premiere. And I'm going to check in the resource file. This is going to be under SDK Cross Dissolve GPU under the category SDK. So let's go ahead and check our project debug settings. In this case, we do not have a target path. We'll need to then go into Premiere and grab the exe. Now let's go ahead and see if we can build and run this. It's asking that I save an SLN file. We'll just hit save. So I'm going to go ahead and reload the project, see if that fixes my saving problem. Looks like it doesn't want to. So maybe if I just name it something new. Apparently it already exists. Let's try 3. I guess we need a new solution file. All right, so we have a few issues here. We can't open a config, or we have an issue with the custom build for the R file. So it's not too common you have issues with your R file building, but in this case the issue is because in our R file settings, I'm comparing it to another project here, we have these AE base paths set up, and these are only going to be relevant if I'm referencing an After Effects plugin. Because I merged the folders here between the PR and AE it's going to have to be put in manually, but that's no problem. We're just going to replace all of the references here with the correct ones. All right, so now if we try and build that, it looks like we get success. We just needed to update those R paths as well. So if you are porting this to not be GPU or just want CPU, first get rid of the GPU file. Make sure you include the right header and util path inside of your project properties, inside the additional includes, and then inside of your R file, anytime it says like the AESDK macro, just replace it with the actual absolute reference to that folder. Because if you do merge these together, it can be a little bit different. So now if I go ahead and hit the run and debug button, we should have a successful build and Premiere to then launch. I'll go ahead and load up a test project, and then to apply, we'll just need to navigate between two clips, go down to video transitions. And in this case, it looks like we don't have it exported correctly. So let's check out the properties for our project again. And it looks like the output directory, we have not defined this as a macro before. So I'm going to just manually say, go to the common plugins, 7.0 media core. You can put it in whatever folder you want. And now go ahead and restart our debugging with Control Shift F5. And hopefully now we should have under video transitions, the SDK folder, which will then have our first build of the transition. Let's go under video transitions, and now you can see we have this SDK folder. We will zoom in here and drag our transition between the clips. And congratulations, you've now successfully built your first basic transition. This is of course just the build process, and it's going to of course be a little bit slower because we are just using the CPU version. But the concepts now that we want to learn are kind of how do we get the two different layers that it's transitioning between. How do we get the effect worlds for those so we can reference their pixels, and then how do we actually go about doing the math to get from one image to the next. In this case, as you can imagine, it's kind of just an opacity change. But let's go ahead and take a look at the physical code that's causing this cross dissolve to happen. Okay, so we'll go back into our cross dissolve CPU, and inside of here, we'll just need to go and reference our render function. Inside of here is where everything's going to happen. We're going to both get our layers inside of here, our clips in this case, and all of the properties and stuff will be set in here. So the first thing we do inside of render is we check out our transition input. Looking over at our header file, which contains usually all of our useful information, our SDK cross dissolve one. This has all of our enumerated properties. So we have our input, which you could think of as maybe the layer. You have the flip, transition input, num_params. Actually, if we click on it, we can see, should be able to see in the effect controls, we have just a flip property. The other two, in this case, are the actual layers. So if you're used to making plugins at all in After Effects, if you're familiar with the enumeration in the H file, you always start with input equals 0. This enumerated property here is always equal to the layer you apply an effect to. This goes the same for Premiere, except in this case, it's going to refer to you could call it the A layer, the one that comes before the transition is going to be this input. Then we have a whole list of all of our interface properties, and you can duplicate that and mess with it as much as you want, which is fine. But then after that, instead of ending it with num_params, we're going to end with transition input and then num_params. So we're going to first check out that A input, that's the first clip, and store that into our param. And then we're basically going to set up two things. You can see here, this is our very simple A and B layer or clip definition. Our incoming layer is going to equal a pointer to our param and the layer def of it. The outgoing is going to reference all of our params, the 0th index, and then that layer def. And here's how we get the output. Usually you have this output here, which is the ultimate endpoint of where the image gets displayed to. This is going to be referenced, basically, we create a variable called destination, and we're going to set it to our output. So we have our outgoing, our incoming, these are our A and B transition layers, and then we have our destination output where the final image will be plastered onto. After that, we are going to set up constant characters to represent these worlds for outgoing data, incoming data, and destination data. And then inside of here, we have our simple function, which we're going to loop through all of our pixels row by row. This is a manual way of iterating through the pixels where we go from 0 and then we go to the max, the output height of our image, which is going to go row by row by row. Now for each of those rows, we're going to loop through the number of width pixels. So we're on row 1. We're now going to go into this X for loop, which goes from 0 all the way to 1920 or whatever the width of it is. So it's going to go through each of those pixels. And then inside of this loop is where all of the magic happens. This code is super minified to a degree where there are a few casts going on in here, but these are all ternary operators, which make it super simple to write more minified code. So what we have are 4 outgoing variables, one for B, G, R, and A. And that should be remembered that in Premiere, the pixel formats are UVA or they're BGRA, not RGBA. So for our outgoing B color, it's going to be equal to our outgoing data. It's going to be set to either this value here or 0. Let's break this down because this is how most of this is actually functioning. Basically, what is the outgoing data? The outgoing data is what our B transition clip value is. What this is saying is that the outgoing B value, it's going to be a float value. We're basically going to try and get the actual B channel value for a particular pixel. We're looping through all of our pixels. This is the one we're focusing on this particular B channel. If the outgoing data exists, basically if the outgoing data that we set up here doesn't have some kind of error or isn't null, if that's the case, this is the if statement. We're going to set it, outgoing B, to our outgoing data pixel x times 4 plus 0. Now let's discuss this really quick. X times 4 plus 0 is the way we are getting the actual pixel here. What this means is that we have our outgoing data. This is going to be equal basically to a giant continual array of pixels representing our entire image. In order to get the current index, we're going to say x. So x could be 0, x could be half of the comp width, x could be the comp width. We're going to multiply that by 4 because that's how many channels there are per pixel. We have R, or in this case, BGRA. So if x is equal to 1, the first R or the first B value is going to be the 0th value. The G value is going to be the first value. The R value of index 1 is going to be the second value, and the A index is going to be number 3 of the first value. This is basically a way we get each of the individual channels from a particular location when we have our effect world formatted as a const char type of deal. So basically, we're iterating through our entire width using x. On each step of the x, we're getting the 0, 1, 2, 3, 4 value, which gives us BGRA. Once we get to x equals 2, BGRA, x equals 3, BGRA. And this is the way we get that. We basically convert it to a float, a const float, using our outgoing data from the current row, reference the current pixel, and the correct channel. If otherwise, we set it to 0. The else statement almost never applies. It's if your pixel is somehow bad or maybe out of bounds or something like that. And most of the time, it's going to actually be set to this value here. Now, moving on to the incoming BGRA, this is the same thing. We're checking if the incoming or clip A data is valid. If it is so, we're going to get the current B, G, R, and A values from this current row, the same analogous row to our A and B clip. So basically, each time we get through these blocks of code, we're going to take a look at a single point on our canvas. This single point, we're going to check on both the incoming of the transition canvas and the outgoing canvas of the outgoing clip. That way, our point that we're dealing with here is going to have information for that single pixel for both images. Basically, all of the information we need to transition any given pixel from one image to the next. Hopefully that makes sense, but essentially all we're doing is taking an effect world, which is a common variable type in plugins here, and we're converting it to const chars. That basically gives us easier access to go line by line and easily identify which pixel is which, and depending on how many color channels we have, get the BGRA or the YUVA values for each given pixel. So that's how we are going to get all of the incoming and outgoing data of our given images. This is the raw data, I believe, without any effects applied, because transitions do often cause issues with certain effects applied to them. So I'm not 100% sure, but this should be the incoming and outgoing layers without effects applied. If you do notice otherwise, let me know, but I think that may be the case. Regardless, after that, we have something else very important to learn called basically the progress. Now, these are using other variables like the alpha weighting and stuff, but the main thing you should know about is this progress variable, which is defined here at the top of render. Our progress is simple to calculate. We take the current time that we're at, the current time of the rendered frame, divided by the total time. So if we're 50% of the way through our total time, which in this case, our total time is going to be equal to the total time of our transition, not the total time of the clip. It's the total time of our transition because it's based on the in data. So it's going to give us a percentage between 0 and 100%, in this case in decimal form, so 0.00 to 1.0. And with that progress value, we can then dictate a lot of things. If we multiply any value by our progress, that value is going to gradually increase as the time value increases on our transition. And if you want, you can also do the inverse of the progress. So if you wanted to have something go one way as the time goes up and the other way as the time goes up, then what you could do is do the reciprocal or the inverse here, 1 minus the progress, to get the opposite. And then you'll get the multiplier to go down as the time increases. I highly encourage you to mess around a lot with these particular lines of code because this is the main meat in terms of creating these plugins. So to briefly sum up again, we have our progress and these other variables which we don't necessarily need. And then finally, we're going to use the same kind of indexing method to get the x values times the number of channels plus the actual channel index 0, 1, 2, 3 or BGRA. And we're going to be applying this to our destination data. You kind of have to ignore the large amounts of casting going on, but basically we're casting these chars back into float format, so they're, instead of being 0 to 255, they're going to be in a floating format like 0 to 1.0. We're going to apply for each of our channels a calculation of all of our outgoing and incoming values times whatever weighted thing you want. Now this is obviously a little bit complicated, all these alpha weighted and stuff, so let's go ahead and simplify it. Let's set our outgoing color to be our outgoing B times our progress. In fact, let's do it for each of them. We're going to set each of the outgoing values or the destination values to BG. So we're basically going to see what happens if we multiply the outgoing values by the progress value. This is where we can start messing around, multiplying numbers. And the cool thing about transitions is you have this progress or time element, which is unrelated necessarily to the layers or clips themselves, but gives us a lot of control. And you can start experimenting with a lot of geometric operations over time. So we'll apply our cross dissolve. And let's go ahead and see what this looks like. Remembering, of course, we are using CPU speed, but in this case, let's go ahead and actually just render this section. So in this case, what's going to happen is you can see there's this interesting fade basically that's happening. And why is there a fade happening? Well, if we take a second look at our math, what's going on to our output? What we're doing is we're taking our outgoing pixel values and multiplying them by progress. Super simple. What does that mean? We're taking whatever the output image is, and we're multiplying it over time by a higher and higher multiplier. So at the beginning, all of these values are going to be multiplied by 0.0, 0.0, making all of the pixels black. All of them are 0. And as we get closer to the end of the transition, those values are going to start increasing. So we're going to get more B, more G, more R, and more A. So if we wanted to, we could have a constant alpha value if you wanted to, and then have the rest of them transition. Or what we could do, we could even say, let's say we only want the progress on the B channel. Everything else is going to be set to the outgoing color or the outgoing alpha. And now you can see it looks like we almost have a tint, but what this should create is the effect of a sort of tint increase. So as you can see, it's kind of hard to tell with these flashing lights in the background, but the first thing it did is it started super yellow. That's because the opposite of blue is yellow. So when our B value is set to 0, basically, it's going to be super yellow. But as the progress increases, we're going to start reintroducing those blue colors, finally to reach our final destination blue amount. And remember, it's doing this for each of the pixels. So each of those pixels is running off of the same rules that we have defined here. All right, there's actually a little bit more fun we can have, and that is messing around with not just the progress, but also the X and Y values. Having relationships geometrically between the progress we've set up or the X and Y values of the individual pixels we're looking at is pretty interesting, because what this basically is similar to shading in geometry, where you have a graph, maybe it's a line like this, and you could say everything that matches my mathematical equation on this side should be colored red, and everything on this side should maybe be colored blue. We can do the same thing to have everything on this side be the incoming pixels, and everything on this side be the outgoing pixels. So how I foresee doing this is, let's have our input pixels be the same as the input, and have all of the output pixels end up being a solid color to make it super simple. So to do this, I'm going to create an if statement and say if x times progress is greater than, let's just put an arbitrary number, 500. Else, we'll do something else. This is just some arbitrary math right now, but putting these if statements is going to start allowing us to create different looks and effects. So this is saying if the x value times the current progress is greater than 500, let's do something. Otherwise, do something else. If x times progress is greater than 500, if it's over here on the canvas, let's say if it's less than, we'll define our incoming pixels, put that in there and this in here. We have two copies here of the same code. If it's less than 500, our incoming B, let's just set to pure blue. Have the other two color channels be empty. Otherwise, use this outgoing data. As you can see as well, I think it wants these defined outside of here. So say outgoing B, outgoing G, outgoing R, outgoing A. Same for incoming. And we don't need these float definers here. And we'll relaunch Premiere and see how this appears. And also, actually, no, I realized, let's just use our, we should actually just have our destination data defined in here, right? So if we're less than 500, we want that to be our input. If it's more, we want this to be the output. So I'm going to put our outgoing text here. Like that. Otherwise, we need to actually reintroduce the outgoing up here and have it down here as well. This will be 1.0, 0, 0. Alpha needs to be 1. Sorry, just a little bit of experimentation here. So let's review. For each time, each frame here, As long as x times progress is less than 500, we're going to set our outgoing data to be whatever the original outgoing data is. The incoming data, same thing. And then we're going to set the outgoing pixel equal to, let's just say the incoming values. And then otherwise, we're going to set the outgoing colors to that and set the outgoing color. We'll get rid of the progress, so we don't need that, and we'll just go ahead and run it in Premiere, see what we get. From here, we can kind of just tweak and tweak until we find something that works and then get closer to our desired effect. A lot of this does need to be worked out mathematically. Geometry was certainly not my strong suit in mathematics, but this has certainly helped give a more practical example or way to learn these kind of things. So apply our transition. And as you can see, we start seeing an effect here. What it looks like we're getting is a backwards wipe effect. So very quick, and it didn't go all the way. So first thing is that this should probably be switched. And let's say if it's greater than our width, something like that, or our output width, maybe divided by 2, try that. And one way you can speed up this process is to also apply your plugin and then save it so it's automatically there the next time we debug. Now you can see we get a different effect. At about halfway through, it starts transitioning backwards. So as you can see, just by messing around with different values like the x value, the progress, and checking if the x times something is bigger than a certain value, then we can start to get some really interesting results. And then just remember the basics here, that it's often a good idea to actually work through the math a little bit manually and make sure everything sounds good. Like, okay, if we have our x value over here at 0, the progress is 100, that's still going to be 0, which is never greater than our output.width. But if we take our x times, that's 1, and then have it equal to max of our progress, 100%, it's then going to just equal 1. So maybe if we multiply the width by the progress, we can get a more interesting result instead of multiplying the x by the progress. These are all kind of time-sensitive variables which change over time, and getting used to how they work intuitively in your head can be difficult. So again, writing down the actual geometric descriptions of what you want to achieve can also be very important. So let's take a final render and a final look at what we've created. As you can see, we have a transition. The clip changes because we set that up incorrectly, but we have this basic transition going through here. And that's just kind of the basics I wanted to teach about setting up and going over the basics of how to adjust the individual pixels and things over time in a Premiere plugin. Again, make sure you check out the cross-dissolve Premiere SDK example. It's going to have all this information from getting your progress variable, getting the layers, getting the outgoing and incoming data, and setting those to the physical, almost memory locations to adjust the pixel values. And using the example is going to be super helpful in letting you understand how to set these values, how to transition from image A to image B, and how to do more geometric mathematical operations. I hope you guys enjoyed this video. If you did, hit the thumbs up button. Down below, hit subscribe and the bell icon to be notified of new videos coming out twice weekly in the channel. And down in the description, you can follow us on GitHub for coding updates, as well as Instagram for other live updates. If you haven't already joined our Discord server, make sure you do to get help with scripting, extensions, plugins, expressions, submit tutorial ideas, and much more. Also, if you want to talk about these new types of transitions I'm going over, new for the channel that is, this is the best place to do that. And also, you can check out the links in the description to become a channel member on YouTube, which gives you cool perks and helps us out financially. As well, check out the links down below to AE Scripts, Gumroad, and Adobe Exchange to see some other cool stuff I make. Thanks again for watching, everyone. We'll see you next time.